Welcome back, math fans. In this video, we will take a look at the rational numbers. That is the first group of real numbers that we are going to focus on. So let's talk about what a rational number is. A rational number is a ratio. If you look really carefully, you can see the word ratio right in there in the name rational. So this is a ratio of two integers. Remember that the integers include the negatives, 0, and the positives, but we're only using whole numbers. We don't have any decimals or any fractions in here. A rational number looks like maybe 1/2. Or it could be -3/4. It could be +6/1. That 1 makes any number a rational number. As a general form, we say that a rational number is a ratio of any two integers. So we can say A and B are integers where B cannot equal 0. When B is 0, that means we have a number divided by 0 and we don't go there. I'm pretty sure that might be how COVID started. Somebody tried to divide by 0. So we don't do that. That's why we throw B out. When we talk about A over B, remember from a very, very long time ago that A is known as the numerator. That's the top number. B is the denominator. That's the bottom. And if you have trouble remembering which one is numerator and denominator, D also starts the word down, so the denominator is down below the numerator. Now, we have what we call proper fractions and improper fractions. And we're not talking about how they behave when they have tea with the queen. We're talking about their form. We say that a fraction is a proper fraction when its numerator is smaller than its denominator. So that would be 1/3 or 5/7 or 3/4. Those are proper fractions because the numerator is smaller than the denominator. A fraction is an improper fraction when its numerator is larger than its denominator. So this could be 6/5, 3/2. Those are some examples of where the numerator, the top number, is larger than the denominator. Let's look at a couple of examples to identify a fraction as either proper or improper. To do that, we need to take a look at the numerator compared to the denominator. In this case, our numerator is 3. Our denominator is 2. And at this point in time, you have been around math long enough to know that 3 is greater than 2. So that means that this is an improper fraction. We'll slide over to number 2. Again, we are going to compare the numerator to the denominator. I have a numerator of 6, a denominator of 11. 6 is definitely less than 11, so this is a proper fraction. We'll look at 2 more. Again, we're going to compare the numerator to the denominator. Our numerator is 41. Our denominator is 40. 41 is definitely greater than 40. Our numerator is larger, so that means we have an improper fraction. I stuck number 4 in here because not only do fractions make people nervous, negative fractions send them over the edge. But what we're going to do is pretend that this negative isn't even there. We are still only going to focus on the numerator and the denominator. Now I know that 9, that is the wrong color blue. 9 is smaller than 10. That means that even though we had that pesky negative symbol, this is still a proper fraction. Then we can go back and bring back our negative, and it's still a proper fraction. So the sign in front, it doesn't affect whether it's a proper or improper fraction. It's just the size of the numerator and the denominator. Now, one thing that tends to get left out of the proper versus improper fraction conversation, I'm going to stick over here on the edge. We talked about what happened when A is less than B, when A is greater than B, but what doesn't often get talked about is what happens when the numerator equals the denominator. So you have a fraction that looks like 3 over 3. Now, most people by now automatically take a look at that and say, oh, that's equal to 1. But here's the catch. If A is equal to B, if the numerator and the denominator are equal, we still consider this an improper fraction. So file that away, put a big star by it, so that should it show up in a problem, you've got that right there to refer to. Now let's go take a look at mixed numbers. That's a different type of rational number. A mixed number is the result of simplifying an improper fraction. It has a whole part or an integer part. And a fractional part. So it would look like maybe 2 1/3 or 4 5/6 or -6 3/5. Each of these has an integer part and each of these has a fractional part. So here's the fractional parts. Now, you might be thinking, okay, Ms. Graham, you said that mixed numbers can be the result of simplifying an improper fraction. How do I take one of these things and turn it back into that improper fraction? Well, I am incredibly glad you asked, because here we go. In order to convert a mixed number back to an improper fraction, the first thing we're going to do is multiply the integer by the denominator. Once we do that, we are going to add the answer from step 1, so that part right there, to the numerator. The last thing we're going to do is take the answer from step 2 and put it over the original denominator. And I know when you read that, it can be super confusing all at once, but I promise we are going to do some of these together. So we'll take a look at example 1. Step 1 said multiply the integer times the denominator. So I need 1 times 5. So this was step 1. Step 2 said to take that answer and add the numerator. Step 3 said to take that answer, so the 9, and write it over the original denominator. So 1 4/5 is the same as 9/5 if we change it back to its improper form. So we'll do another one. I'm going to write out the steps because I am a steps kind of girl. Step 1 said to multiply the integer times the denominator. I know that 1 times anything is the thing, so 1 times 20 is 20. Step 2 said to take that answer and add the numerator. Well, 20 plus 7 is 27. If you need to use a calculator, please, 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 please use a calculator. Don't feel silly for wanting to pull out a calculator and double check your answers. I would rather you pull out a calculator for 20 plus 7 and get it correct than feel stupid because you had to pull out a calculator and get it wrong. So pull out a calculator if you need it. If anybody gets upset, tell them to mind their own business. Now I'm going to take the 27 in step 3 and I'm going to put it over the original denominator. So my improper fraction becomes 27 over 20. Two more. Step 1, I'm going to multiply the integer and the denominator. Then I am going to add that answer and the numerator. And I'm going to take my new number, my 7, and put it over the original denominator. So 2 1/3 is equal to 7 over 3. I changed up number 4 a little bit. I'm going to go a little bit faster. I'm not going to write out all the steps. I'm going to do 6 times 4. I'm going to add the 3. So I get 27, and then I write it on top of the original denominator. So 27 over 4 becomes my improper fraction. So now we're going to do this the other way. We are now going to go from an improper fraction to a mixed number. So to do this, we are going to go way back to elementary school. We are going to go back to when you first learned long division. And we are going to do the numerator divided by the denominator and we're going to use the old school number outside the house, number inside the house format. We're going to write down that result. And then we are going to take hold of that remainder as the numerator of the fractional part. We're going to keep the original denominator. And that's a lot. So we're going to do it together. So when I look at number 1, I would initially say 20/3 as reading the fraction. But what that really means is 20 divided by 3. So here we go with some old school long division. I know that 6 times 3 is 18. If I put a 7 up here, I know 7 times 3 is 21, and that's bigger than 20, so I can't use the 7. 6 times 3 is 18. If I do 20 minus 18, I have 2 left over. Remember that these leftovers become your remainder. So our answer to 20 divided by 3 would be 6, remainder 2. That's great, Miss Graham, but what does that mean to me? Here's what it means. We did the long division. That was the first step. Second step says write down the integer or the whole number part of the answer. We did that part. Write the remainder, so the 2, as the numerator. Keep the original denominator. So my 2 goes on the top. My original denominator goes in the denominator. So 20 over 3, or 20/3, is equal to 6 2/3 as a mixed number. So practice it again on number 2. 2 says 31/10. This is the same as 31 divided by 10. Well, I know that 3 times 10 is 30. When I do 31 minus 30, I get a remainder of 1. So I write down the whole number answer. Then I make the remainder, the numerator. And I make the original denominator the denominator. So 31 over 10 is the same as 3 and 1/10. Two more. This would look like 9 divided by 4. Well, I know that 2 times 4 is 8. You remember, I want to get as close as I can to the number on the inside without going over. 9 minus 8 is 1. So my answer would be 2 with a remainder of 1. I keep the integer part. The remainder becomes the numerator. The denominator stays the same. So 9/4 is the same as 2 and 1/4. Last one, I suggest you pause the video, try it yourself, then play the video and check your answer. I know that I can multiply 2 times 3 and get 6, and 1 more makes 7. If you want the whole thing divided out, this is what it would look like. 3 times 2 is 6. When I subtract 6 from 7, I get a 1. So my whole number part goes there. My remainder becomes the numerator, and the denominator stays the same. If you have any more questions about proper and improper fractions or mixed numbers, feel free to shoot me an email. I will see you later in our next